Problem 41. Use the histogram below to answer the question that follows. Here's our histogram. Two six-sided number cubes. They sound suspiciously like regular dice. Two six-sided number cubes are rolled simultaneously 10 times. It's like you're rolling two dice 10 times. The sums are recorded in the histogram shown above. So that when you look at what's on the top of your dice and you add them up, and then they recorded the frequency of the different sums. Which of the following statements can be inferred from the histogram? So the first one says the mean is less than the median by 1/10. The mean, okay, so they're comparing the mean and the median in every one of these choices. So we can actually look at this histogram and figure out all of the results that happened. So the sum, we got three times. So we got three threes, 3, 3, 3. We got 1 4. We got 3 5s, right? 5 had a frequency of 3, so 5, 5, 5. And then we had no 6s, and then we had 3 7s. 7, 7, 7. So the median is easy to figure out. The median is literally just the middle number. So how many do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the middle number is going to, or the middle two numbers, because it's an even, and if they're not the same number, we're going to have to take the average. So what's the middle number? If we have 4 on this side and 4 on this side, the middle numbers, right, because we have an even data set, are 5. So the median here is equal to 5. Now the mean is going to take a little bit of more mathematics. We're going to have to sum up all of our results and then divide by the total of data points there are. Well, actually, I should have known that there are 10 data points. We're going to divide by 10. So what's the sum? It's 3 times 3, so this is 9, plus 4, plus 5 times 3, or 5 times 3 here, which is 15, plus 7 times 3, which is 21. So 9 plus 4 is 13, plus 15 plus 21. This is 13 plus 15 is 28 plus 21. 28 plus 21 is 49. And if we have to divide that by 10, we get an average. So if you divide it by 10, because we have 10 data points, the average is going to be equal to 4.9. So our average is 4.9. Our median is 5. So our average is 1/10 less than our median. So or when I say average, I actually say mean. But it tends to mean, when people say average, they tend to mean the mean. Our mean, when we just add up all the data points and divide it by 10, is 1/10 less than the median. So let's see. The mean is less than the median by 1/10. That looks right. Our mean is less than the median by 1/10. Choice A. Problem 42. Use the graph below to answer the question that follows. Distribution of test scores. All right. The graph above shows the distribution of scores on a test with possible scores of 10, 20, 30, 40, 50, and 60. Those are the only possible scores. Maybe there are only 6 questions on the exam. Well, yeah, sure. The minimum passing score was 40. So this is the minimum passing score. You have to get at least a 40 to pass. 20 girls and 20 boys took the test. The percentage of girls passing the test was how much greater than the percentage of boys passing the test? All right, so let's see how many girls passed the test. So this dotted graph is the girls. So 5 got a 40, so those passed. They just barely passed. So you had those 5 girls get a 40. Then you had another 6 girls get a 50. So you have another 6 girls get a 50. And then you had another 4 girls get a 60. Plus 4. So that's how many girls passed. So that's 5 plus 6 is 11, plus 4 is 15. Girls passed. Girls passed. There were a total of 20 girls, so 15 out of 20, or you could think of that as 75%. If you divide 15 by 20, that's the same thing as 3/4, or 75% of girls passed. Now let's do the boys, and I'll do it in stereotypical colors. The boys in blue. Once again, they have to get at least a 40 to pass. So 6 boys just barely passed, got the 40. Then 3 boys got a 50, they passed. Plus 2 boys got a 60, they passed. So a total of 6 plus 3 plus 2 is 11 boys passed. 11 out of 20 is the same thing as what? That's 55%. If you multiply the numerator and the denominator by 5, you get 55 over 100. So this is equal to 55% of the boys passed. Now, what did they ask us? I forgot already. The percentage of girls passing the test was how much greater than the percentage of boys passing the test? So 75% is how much greater than 55%? Well, 75% minus 55%, that's 20%. The girls' percentage is 20% larger than the boys' percentage. It was larger by 20%. The percentage of girls passing the test was how much greater than the percentage of boys passing the test? Right. It was 20 percentage points greater. Next question. 43. Use the table below to answer the question. I think I've learned that. A marketing company conducted a survey to determine milkshake flavor preferences among 5 different age groups. These are the different age groups. Are the different options, I guess, of milkshakes. Based on the data in the table, what is the probability that a randomly chosen 35-year-old customer will prefer a strawberry-flavored milkshake? So a randomly chosen 35-year-old, that puts us in this bucket right here, 30 to 39-year-olds. So if they can be described by the data that we've collected already, the probability is the same ratio of the data sample we've collected that actually liked, strawberry flavored milkshake. So in that age group, how many total people did we survey? We surveyed 8 plus 14 is 22. 22 plus 12 is 34. We surveyed 34 people in this age group, and how many of them liked strawberry milkshakes? Well, 12 of them did. 12 out of 34, 30 to 39-year-olds liked strawberry milkshakes. So the probability, if we use that as our data, that a random 30 to 39-year-old will like strawberry milkshakes is 12 over 34. Or if we reduce this, that's 6 over 17. Just divide the numerator and the denominator by 2. And that is D. Good thing that was one of the answer choices. D. Problem 44. Problem 44. A child has a set of blocks, 4 of which are square. So we have 4 square. 5 are round. 5 are round. And 6 are triangular. 6 are triangular. The child randomly picks a block from the set and gives it to his sister. The child then randomly picks one more block. So he didn't put that block back in. That's very important, that the first block. What is the probability that the first block was round, and the second block was triangular? So the probability the first block is round. How many total blocks do we have to start off with? We have 15, right? 4 plus 6 is 10, plus 5 is 15. So we start off with 15 blocks. And what is the probability the first block is round? Well, 5 of them are round. So there's a 5 over 15 probability. So this is the probability that first is round right there. And now what is the probability that the second block is triangular? Now, remember, we no longer have 15 blocks in the pile. Now, he's taken one of the blocks and given it to his sister. So now we're choosing out of 14 blocks. Now, and we're also, and this is an and, so we're assuming, so what is the probability that the second block is triangular given that the first block was a circle? So we assume that we still have our full contingency of 6 triangles there, that wasn't picked our first time. So the probability that the second block is triangular, there's 6 triangles. There's 6 triangles out of the 14 blocks left. So our answer is going to be 5 over 15, which is the same thing as 1/3, times 6 over 14 is the same thing as 3 over 7, which is the same thing as 1 over 7, and that is choice C. Problem 45. Use the spinner below to answer the question that follows. Okay, there's our spinner. The host of a party tells her guests that every time the spinner above lands on the section labeled fruit basket, that's the section labeled fruit basket, a guest will win a large basket of fruit. If the 180 guests at the party each spin the spinner once, what is the best estimate of the number of fruit baskets that the host will be giving away. So let's see, we have, looks like 1, 2, 3, 4, 5. They look about equal. So you have 5 equal pies. So it looks like there's a 0.2 or 20% chance of getting fruit basket. So each person can almost pretend like they get 0.2 of a fruit basket. So they have 0.2, or maybe I should say they have a 1/5 chance. And then you have 180 of those people. So times 180. I could have multiplied this times 180. This would be the expected value, the expected number of fruit baskets I'm going to give away. So what's 1/5 times 180? Or well, how many times does 5 go into 180? 5 goes into 18 3 times. 3 times 5 is 15. 15 minus 15 is 3. 30, 36 times. So I would expect to give away 36 baskets.